Hi everybody, in this video we want to talk about the concepts of magnetic resonance imaging, okay, and get familiar with these curves and these schematics. Well, the MRI technique is based on applying an external magnetic field and also a radio frequency wave. You know that for the MRI the person is put into this big hole and we want to see what is happening inside here. As you know, our body contains a lot of water molecules, and the water molecules have the hydrogen atoms, and these atoms have the magnetic spin. Okay, now when we are in that hole and the externally applied magnetic field is present, our water molecules, the hydrogens to be more precise, will align themselves with respect to these magnetic lines. And here you can see what happens, that the hydrogens will align their magnetic spins parallel to these magnetic lines. Okay, now if an additional radio frequency is emitted here, this alignment will be disturbed. As you see here, now the radio frequency comes and they are disturbed, okay, so they do not have the previous order anymore. But after the wave is going, after the wave is gone, you see that these magnetic spins again they tend to align themselves with respect to the previously applied magnetic field. And here we want to see exactly what is happening, okay? Well, if you consider this direction as the direction of the applied field, okay, we want to see when the radio frequency is applied and the magnetic spin is disturbed, we want to check the net component on the xy plane and the net component in the direction of the z axis. Okay, well, let's consider this yellow as the magnetic spin of the hydrogen. This grain vector is the image of this vector on the xy plane, and as you see here, this gray vector is the image of this vector on the z axis. Okay, so when the radio frequency is applied and the magnetic spin is disturbed, it will tend to again align themselves here with respect to the magnetic field. Okay, if we measure these two components, the image of this on the z axis and the image of this on the xy plane, we will get two physical properties which can be used for the MR imaging. Okay, as you see here, as it is spinning, this amount is increasing and this amount is decreasing. Okay, you see here it is decreasing and this one is increasing. And this is what exactly happening in these curves. Okay, you see that the component along the z axis is increasing by time, and the component along the on the xy plane is decreasing by time. You saw here that this is for the xy plane decreasing, and for the z axis it is increasing. Same as here, the decrease for the xy plane and the increase for the z axis. The measuring of these two properties gives us the relaxation time T1 and the relaxation time T2. Okay, these two components can be used for processing the MR images. Well, in the field of MR imaging, we can exploit the nanoparticles to improve the contrast of the images that we get. One of the most useful nanomaterials for these applications is the use of iron oxide nanoparticles or the magnetic nanoparticles. You know, the ferromagnetic iron oxides, okay, they have the large magnetic susceptibility, and this phenomenon, this property, can persist even upon the removal of the external magnetic field. It means that if we apply a magnetic field and if we remove it, okay, for the ferromagnetic materials, the magnetic property is still present in this ferromagnetic material. But for the nano-sized iron oxide particles, they become super paramagnetic. It means that if we apply a magnetic field and we remove it, they will lose their magnetization when the external magnetic field is absent. Okay, so we can locally introduce the magnetic nanoparticles in the tissues, okay, to improve the quality of our images that we get with the magnetic resonance technique. In this picture, you see some of the most popular magnetic nanoparticles that have been used as the T2 contrast agents. I have to remind you that, as you see here, these magnetic nanoparticles, they shorten the T2 relaxation time, okay, and the contrast related to the images taken by this phenomenon, this property is improved, okay. As you see here, there are many types of the magnetic materials. These are the cores, and these are the shells, and the other information which are not important a lot for this course. All we have to remember is that the presence of the magnetic nanoparticles will increase the contrast of the images. Don't forget that in the field of fluorescence microscopy, these were the fluorophores which emitted light, okay? But here, the nanoparticles, they are not emitting light. Only the presence of the nanoparticles will help us to increase the contrast, and this is why we call them the contrast agents, while for the fluorophores we use the name of tracer for those imaging modalities. Okay, never forget that.